This is a video that talks about cement production. So the outline of the video, I'll be talking about the manufacturing of ordinary Portland cement. This is the most common type of cement. And then I'll be going through some environmental concerns that are associated with cement. So for cement production, what you need to produce cement is you need to grind Portland cement clinker with calcium sulfate. And calcium sulfate is gypsum. The reason that this has to take place is because we need to stabilize the clinker, and clinker is a main product that is produced during this production process. In terms of the requirement for gypsum, well, the standards, the Australian standards, they do specify a certain limit in terms of how much percentage of gypsum you can mix with your cement clinker. But as we will see in a different video, gypsum is important in the control of C3A, the hydration of C3A, and thus it avoids flash setting from taking place in your concrete mix. As I said, an important product is clinker, and that's produced when your limestone and clay are burnt together in the cement production process. Another important product is your Portland cement, and this is produced when we grind the clinker with small amounts of gypsum towards the end of the production process. Now, in terms of the clinker product, it's created, as I said, from mixing of the calcium carbonate bearing materials, so the lime and clay, and then both of these products, once they're mixed together, they're burnt at a very high temperature. We're talking about approximately 1500 degrees Celsius. In addition, we need to understand that there has to be less than 4.5% of the total mass of magnesia in your cement product, and that's to avoid any excessive expansion that takes place when the magnesia would react with the aggregates that are present in your concrete mix. So what's the manufacturing process of cement like? This is just a brief summary of the cement making process. I'm going to go through each of the main stages. So stage one is the quarrying. You've got to quarry the limestone, of course, so you use an excavator to do that. The excavator then loads your dump truck, and then that would go to the manufacturing plant. And this is where stage two would start. So stage two of the cement production process, this is where your limestone rock that was collected in the first stage, this is where it's crushed into smaller pieces. And the process is usually done with the stone being dry. However, if you have wet stone, then it has to go through a rotary dryer in order to ensure that it's dry enough. Now stage three is where the materials are blended together. So the limestone is blended with your with clay, and it has to be done in the right proportion in order to produce a stable cement product at the end. And then that mix undergoes further grinding, and the material is then wet before it's moved on to the kiln. And then in the kiln, that's where the burning takes place. It's very high temperatures, but the burning itself, you can think of it as undergoing three main processes. So the first process takes place at 950 degrees Celsius, and that's where the decarbonation of limestone takes place. And you can see the chemical equation for that. So you have your calcium carbonate, it disintegrates into calcium oxide plus carbon dioxide. So the carbon dioxide is the greenhouse gas emission, and that's why it's a very environmentally expensive process. That's because of the release of this carbon emission. So this happens at 950 degrees Celsius, and then at 1350 degrees Celsius, C2S starts to form, and it's formed because there's a reaction of the calcium oxide that was formed from the first step that happened at 950 degrees Celsius. So the calcium oxide reacts with the silicates that are present in the sand and clay. And then the third process is where C3A and C4AF is produced. And then C3S is also produced at that process, and this happens at approximately 1450 degrees Celsius. And C3S is produced once C2S reacts with the remainder of the calcium oxide that's present. Now, the final stage in the manufacturing process of cement involves the crushing of the burnt material. Before you crush it, you have to cool it down. So you cool it down from 1450 degrees Celsius down to 80 degrees Celsius, and that's just to stabilize the C3S. And then once it's stable enough, you add gypsum to it. Gypsum stabilizes the overall mix. As I said, it avoids flash setting. And then you crush it further, and then you process it, and it's ready to go. So, the environmental concerns that are associated with the process. As I just explained, the decarbonation process itself releases a lot of carbon emissions, but that's not just the only environmental disadvantage of the process. The process itself is very energy intensive. Now, this energy requires a lot of fossil fuels, it requires a lot of carbon emissions, extra carbon emissions to be burnt in order to supply energy to the production plant. As you can see the figure in front of you, statistically 4.8% of the total carbon emissions worldwide are produced due to the cement production process. And that's why you find a lot of researchers are concerned with alternative green cements, cements that don't have as much clinker, that don't require as much clinker to be produced. And another sort of method of making the full process less environmentally expensive is through ensuring it's efficient. You could do that through maybe lowering down the energy requirements, so coming up with a product that doesn't need as much energy in order to reach these highly excessive temperatures.